Okay, the first one asks for the coordinates of the maximum turning point of G in the given interval. That was easy, ne? That point right there. It's the maximum point. It's 30 degrees and 2. You agree with that? Okay, next up. Determine the values of x where f is strictly increasing in the given interval. So f is going to be this flat graph. So it's increasing from negative 60. There it's increasing. No, it's not a turning point, so we can assume it's increasing up to the point of 0 degrees. After 0 degrees, it will decrease. Now, the reason they use the word strictly increasing is because it mustn't be turning at that point. So negative 60 is included, but 0 will be excluded. It's the same as the parabola. Do you remember we said you put a ruler on it? And at that point, if you had a ruler, it would be flat, it would be constant, it's not increasing. So therefore 0 will be excluded. That's the reason for the round bracket. Okay, determine the values of Q and B. Now if I look at F's function, it's cos x plus Q. So that graph is perfectly fine. There's no amplitude that's different. So if that plus Q was not there, where should that graph have started? At 0 and 1. So it's starting at 0 and a half. So do you agree with me? We can know that Q is going to be equal to negative a half. Do you understand how I get to that? Okay, and then B. B is the value that influences the period of the graph. So a standard sin graph takes 360 degrees to complete that full wave. This one takes 120 degrees. So the formula we have is that we take the standard period divided by B, it will give you the graph's period. Do you agree? Now I have the graph's period, 120. I have the standard period, 360. Now I want B. Do you remember the shortcut when the unknown is the denominator? You swap it with the answer. So therefore the calculation we are going to do is going to be 360 degrees divided by 120 degrees. And that's how I get an answer of 3. You don't have to show the calculations, but I'm showing it to you so that you understand how I get to it. So therefore B is equal to 3. Okay. The fact that this 3 is there is telling me that I'm correct. Ne? Do you agree with me? Okay. The next one was a bit tricky. Ne? So they're asking, use your graphs to determine, so that means not algebraically, not with a sum, the values of x for which 2 cos x times 3 sin x minus sin 3x is greater than 0. Okay. This is pretty confusing, do you agree? Because that's not the cost that I have, and neither one of those are the sins that I have. Okay. So what I'm going to do is I'm going to try to manipulate this thing so that it looks different. Okay. Do you also agree with me? The sums that we're used to, where they ask greater than or smaller than is when two graphs multiply with each other. When two graphs multiply with each other, then I know the one must be positive, the other must be negative for smaller than 0. Or both must be negative, both must be positive to get it greater than 0. So I need to do something to that. Now, do you see something that I can do in that graph? Factorize. I can take out a sin 3x. And then what would remain is 2 cos x minus 1. Now if you look at that, that's still not the graphs that I have. So the problem with this one, and I am sorry I forgot to tell you yesterday, is that there was an addendum with this where they told us, not an addendum, what do we call it? Errata. So that tells us there's a mistake on the paper. Okay, so the mistake was that there should be a 2 as well. Now if we do it together and I take out that 2 as well, because now I can take it out in common. Do you agree now it's the graphs that I'm referring to? So what they're asking me is where these two multiply with each other to give a greater than 0 sum. Answer. Does that make sense? So despite the mistake there, do you understand what you would have done? No, I'm lying. It's not this one. Askies. Let's just get it back to what we had. We had sin 3x bracket 2 cos x minus 1. Back to that. Sorry. Do you forgive me? Dankie. Does someone need the pics? I have. Okay. It's not this one, it's the other one. You agree this is not right. This is not the function that I have. What should this one be? I want it to be cos x minus a half. Do you remember? Okay. How would I get that 1 to be a half? Divide by 2. So I am actually taking out a 2 in common. Then I'm left with cos x minus a half. Do you understand it now? All of you. So they're actually asking me where did these graphs multiply to give me an answer greater than or equal to 0. So it's the same as that question where I have g of x times f of x greater than or equal to 0. Does the question make sense now? And now it's easy to answer. So how do I get a positive? Both negative or both positive? So I'm going to use my highlighter. Positive, I'm going to highlight yellow, so the ones at the top. And negative, I'm going to highlight pink. It's a pang. Very dumb. Okay, look how easy this question is now. One graph positive, one graph negative. So that's not what I want. No. Yes, both of them are yellow. Yes, both of them are pink. So do you agree with me? From 0 up to 120. I would get an answer greater than or equal to 0. Mels, do you understand? You are frowning a bit. 0 to 120 degrees. Must 0 be included or excluded? Included, because the question is greater than or equal to. 120 included or excluded? Included. So my answer is from 0 to 120. We came across things like this at the algebra as well. Do you remember? Then you like have part of the hyperbola's equation but not the whole thing. Or you'd have part of this one but not the whole thing. Then you had to manipulate the question to know exactly what they're asking in the end. They can't ask you a subtraction sum. And you have to say whether it's going to be positive or negative. It has to be multiplication. So the question has to be manipulated. That will be a level 4 sum. So it is a hard one. It's a bum. Okay, so we're going to draw question 4. I have f of x equal to half tan x, and I have g of x equal to sin 2x. Was it that question 6.4 that was the difficult one for you? Was the rest okay? Okay. They asked you to draw it from negative 90 to 180 degrees. Now remember, this would have been easier because you'd have the answer book. So you'd already have the Cartesian plane. But now we are not afraid of some difficulty. Eh? Now the problem with this is because the one graph is tan and the other graph is sin. Now I told you guys with tan my critical points will be at 45 degrees, but with sin it's at 90, 180 and 30 and 60. So for that reason I'm choosing my 3 centimeters for the sin, although it wasn't actually necessary. Oh, it is, yeah. And I can also insert my 45s. Okay. On my y-axis, tan has an amplitude of a half, so it's decreasing the gradient. Okay. But with sin, I've got an amplitude of 1. So sin doesn't go higher than 1, doesn't go lower than negative 1. So on my y-axis, I'm happy having it from 2 to negative 2. Okay. So let's use tan first. This period, or this b value is 1, therefore the period of the graph is 180. 180 divided by 4, 45 degrees. My critical points will be at 45. So I've got a half tan. I'm going to substitute in 0 first. I get an answer of 0. Then I substitute in 45 degrees. I get an answer of a half. If I substitute in 90, I see I get math error. And therefore, I have my asymptotes. If you knew it from the beginning, you could have drawn it in, it's fine. Then I substitute in 135, I get an answer of negative a half. And when I substitute in 180, I get 0. When I substitute in negative 45, I get negative a half. Do you all agree with that? You understand? So now I just join the graphs. Join the points. Tan graph done. With the sin graph, I see I have a b value of 2. Therefore, I first need to determine where my critical points will be. It's 360 divided by 2. So the period of this graph is 180. 180 divided by 4, my critical points will be at 45 degrees. So I'm starting with sin 2 times 0. It gives me 0. Then I substitute in 2 times 45. Gives me an answer of 1. Then I substitute in 2 times 90. 0. 2 times 135. Negative 1. And then at 80 it's it's 0 again. At negative 45 it gives me an answer of negative 1. At negative 90 it gives me an answer of 0. Now I'm just going to put in my values. The asymptote x equal to 90, x equal to negative 90. They did not ask, they say show all the turning points. So this one is 45 degrees and 1, negative 45 degrees and negative 1, negative 90, 0. 0 and 0, 90 and 0, 135, negative 1, 180 and 0, you don't have to put in those values of tan. It's not a critical, it's not a turning point or an intercept. Are you happy with that? You understand it? Everyone? Okay, the next question, determine the values of x for x, element from negative 90 to 180, for which f of x is greater than g of x. So only greater than, not equal to. So f is the tan graph. And G is the sin graph. Do you see I have a problem there? I'm going to have to read it. And that one right there. And also that one there. Okay. So let's start. I'm going to use a highlighter just to indicate. So here, sin is at the top. There, tan is at the top. Now sin is at the top. Now tan is at the top. Now sin is at the top. Now tan is at the top. Do you agree with me? Those values seem to be easy to read from the graph. You see? No? Okay. So I'm pretty sure that value right there, which is negative 60, is going to be the starting point. Up to 0. And then I'm pretty sure that 60 is going to be the starting point up to the asymptote. And then I'm pretty sure this one here, which is, what is it, 120, is going to be the starting point up to 180. Now the reason I can make that call is because I really did a good job drawing these. They are pretty much on scale. No? But that doesn't necessarily always happen. So if you want to, you are unsure whether that value is negative 60. You can take your calculator. So I suspect it's negative 60. Now I substitute in 0,5 tan negative 60. And I get an answer of negative root 3 over 2. Okay? So I'll remember that one, negative root 3 over 2. Then I substitute in sin 2 times negative 60. And I also get negative root 3 over 2. So I know that's the point where they are equal to. You can do the same for 60 degrees. And the same for 120. But I can assure you it will be the same. So therefore, when I write the answer, it's going to be from negative 60 to 0. And it's going to be from 60 degrees to 90. And it's going to be 120 degrees to 180. Okay, now I just have to determine included or excluded. They're only asking for greater than, not greater than or equal to. So, negative 60 included or excluded? Excluded. 0, excluded. They are equal to each other there, ne? Don't want equal to, I want tan greater than sin. 60 degrees included, excluded? Excluded. They are equal to each other there. 90 degrees included, excluded? Excluded. It's an asymptote. Asymptote always excluded. 120 excluded, 180 excluded. Do you all understand that? Happy with it? Okay. 7.3, they're asking for the period of g of 2x. Now, do you remember at algebra what happened if they put in a value in the place of with x in the bracket? Do you remember or not? Okay. If they had said g of x with a 2 in front, let me write down g. G is sin 2x. If they put it in front of the function, the 2, you have to put the 2 in front of the function. If they had said g of x plus 2, you would add 2 to the function at the end. But what they said was g of 2x. That means it mustn't be added or multiplied or done to the function. It must be done to the x. So therefore, in the place of x, you write what was given there. So if inside it said x plus 10, you would add 10 to the x. You write what it says there in the place of x. So I have to write 2x. So this new function, the period that they're asking of, is going to be the sin of 4x. So they're asking what's the period of this one. We take the standard period divided by B, and that will be 4. And when you divide that, the period of this graph will be 90 degrees. Do you all understand? Okay. Let's move on to question 5 and question 6. Right. These graphs are drawn for me, ne? So they are right. I know it. This cos is F, that one there. And this graph sin is this one here, this G. Okay, when I look at F's equation, can you see that is the standard cos graph? It's just f of x equal to cos x. Now let's check it on the graph. It's supposed to start at 0 and 1. That's what it's doing. It's at the top, it's going down. When I look at it, it takes 180 degrees from negative 90 to 90 to make the top curve. That's 180 degrees. So if I had the bottom curve as well, that would be another 180, it's 360 degrees. So it checks out, that's the standard cos graph. Doesn't reach higher than 1, doesn't go lower than negative 1. Now let's look at sin. At sin, I see something funny is happening. What do I expect if I didn't have the graph? What happened to that graph? It shifted horizontally. So don't let them confuse you using a variable of b in there. We know it's supposed to be b in there. Okay, that's the variable known to be used. But they can put in a b there. They can put in anything there. Right, but this graph has been shifted. Its amplitude is fine. Its period is normal, 360 degrees, because b value is 1. But because of that variable there, I know the graph has been shifted. So the standard sin, where is it supposed to start? 0 and 0. It's supposed to start there. Where is that point 0, 0 on the graph? It's now there. Can you see? That's where the wave is supposed to start. But now it's there. So what did this graph do? Shifted 30 degrees to the left. No. So what is going to be in that equation? Plus 30 degrees. Do you agree with that? Okay, and that was the first question. Write down the value of b. Positive 30 degrees. If you only write 30, it's fine as well. Write down the period of g. What do you say? What's the period of g? 360. There's no b value in either of them, so it's just a standard period. Write down the value or values of x in this interval for which f of x minus g of x is equal to 0. They're actually asking something else. Is there anyone who knows what they're actually asking me? See if you can manipulate that thing. If I subtract two values, and the answer of that subtraction sum is 0. What does that mean? Give me an example of something minus something that will give me 0. Any sum, normal numbers. What? 1 minus 1. Another example? 2 minus 2. What do you notice about the numbers you're subtracting? They're equal to each other. So what they're actually asking for is, where are these two equal to each other? If I manipulate this, I take that one to the other side, then I've got f of x equal to g of x. Do you see? Manipulate the question to know what they're asking. Can you read from the graph where they are equal to each other? I can. Where are they equal to each other on the graph? Negative 150 and x equal to 30. Easy, ne? So it's just difficult sometimes to know what they're asking. But when we know what they're asking, then what they're asking is pretty easy. Look at how they want to confuse us now. 6.4. For which value of x in the interval is sin 90 minus x greater than g of x? So g of x is the sin graph. Do I have sin 90 minus x, that graph? I actually do. What is sin 90 minus x? Cos x. What's f's equation? Cos x. So that is cos x. So they're actually just asking, where is f greater than g? Can you see on the graph where f is at the top of g? From 150 to 30. Okay, they're only asking for greater than. So tell me, must 150 be included or excluded? Excluded. 30 in or out? Out, excluded. The graph of h is obtained by shifting f 3 units upwards. Determine the range of h. Okay, let's just look at f first. It's the cos graph. What's the range of the normal cos? Range is the y values, no? What's the smallest y value that graph, that cos can reach? -1, and the biggest one? 1. So it would have been -1 to 1. Okay. If it is shifted 3 units upwards, all I'm going to do is I'm going to add 3 to that and add 3 to this. Do you agree with that? So what's -1 plus 3? 2. And 1 plus 3? 4. So the range is from 2 to 4. And both must be included because it touches it, ne? Okay, question 6. You're going to do 6.2 for me, but I quickly want to do 6.1 for you. It's the general solution. But it's that one. Do you remember I showed you a couple of examples of this one, where the functions aren't the same and the angles are not the same? Remember when I had sin and cos, I could divide by cos. But I could do that when the angles was the same. So if the one was x and the other was x, or the one was 2x and the other was 2x. This one is x minus 30 and 2x, so I can't do it. Can't divide with cos. So I quickly want to do that one with you. Okay, we're going to need our books to do it. In order to solve this sum, we must either have the functions be the same or the angles be the same. Now, I will somewhere tell you, Claude, you can't get those angles to be the same. You can't get x minus 30 to become 2x. No way. Can I get a sin to be a cos or a cos to be a sin? Yes. Every sin is a cos and every cos is a sin. You also saw it once again there at 6.4, ne? Good. So if you look at 6.4 that we just did, how did that sin become a cos? The 90 minus. Why do you think it's 90 minus and not 90 plus? It's in the first quadrant. If it was 90 plus, then we are changing signs. Okay, so it's 90 plus. Alright. So tell me, grade 11s, I'm not going to work with this one because it already has an angle being added and subtracted. It seems a bit dangerous to me. If this one was a sin previously, let's say it was sin something 2x and now it changed to cos 2x. What did it have to have there? 90 degrees minus. That thing and this thing is exactly the same. Do you agree with that? So I can't put the 90 in there. I need to take the step back. There wasn't a 90, I can't put it in there. But for this cos to change to sin, I need to put a 90 in front of the 2x. Do you all understand how I did that? I think sometimes you want to put in the 90 there. And then change it to sin. That's not correct. Remember, this is already an acute angle. It's already a reference angle. Now when your functions are the same, you can throw them away. So it looks like this. X minus 30 degrees is equal to 90 degrees minus 2x. The 2x goes over, it becomes 3x equal to 30 goes over 120 degrees plus k times 360 degrees. All right, now I want to know, do you think we can use it as 120 or not? We cannot. What are we supposed to say in there? 180 minus 60 degrees. Do you agree with that? Okay, so it's 180 minus 60 degrees because that must be a reference angle. So it's going to be 3x equal to 60 degrees plus k times 360. Now do you know why I wrote the plus k times 360 already? Because I'm going to divide with 3. And remember, when I divide with 3, all of them have to divide with 3. So it becomes x equal to 20 degrees plus k times 120 degrees. And there I have the answer. Do you all understand that? Okay, now I want you to do 6.2. Now, without my help. You have to draw the two graphs, write down the period of G, state the range of F, and write out the coordinates of intersection for F and G. Okay, you do it now. I'm also going to do it and then I will show you what it looks like. But I want you to put up your hand if you are struggling. Grade 11s, when you study for the test at the end of the term and at the end of the year, I hope you've noticed that the functions, they count like 10 marks in a question paper, so it's not a lot. I will go as far as to say that just doing these papers that I've given to you, it's 6 questions, going through them, working them out, learning what we did, it's efficient to answer the questions. You are welcome to work out other question papers, but this is what they can ask. You've seen, they can only manipulate the question to make it more difficult, but it's the same things over and over and over again. Okay. You can check 6.2.1 and 6.2.2. Are you done with your graphs? Can I show it? Does yours look like that? Hmm? For which ones? Okay, for F, I know my critical points will be 90 degrees. Okay? But the graph has shifted 30 degrees to the right. So instead of using 0, I choose 30 degrees to the right. Instead of using 90, I choose 30 degrees to the right. Instead of using negative 90, I use 30 degrees to the right. Remember that way we've done it. Okay? So I'm not going to choose negative 90. 30 degrees to the right is going to be negative 60. But you type in the equation as it is given there. So it's sin negative 60 minus 30 gives me negative 1. And then not 0 but 30 degrees. It gives me 0. Do you understand? Can you see that? Listen, I want to say this, but I don't want you to be confused. Because the graph was shifted 30 degrees to the right, the value that's supposed to be at 0 and 0 is going to be at 30 and 0. That's why instead of substituting in 0 minus 30, when I substitute in 0 minus 30, remember your calculator does what's inside the bracket first. So it's going to subtract. So this answer that you get is actually the answer that is usually on the original sin at negative 30. But that value is now going to be at 0. That's why when I substitute in 30, the answer I'm going to get is going to be the answer that I usually get when I substitute in 0, if it was standard sin x. Because sin 0 and sin 30 minus 30 is the same thing. But the answer that I get here, 0, mustn't be plotted at 0 and 0. It must be plotted at 30 and 0. Because that's what I substituted in sin x minus 30 degrees. That's the function I'm drawing. I'm not drawing sin x. I'm drawing sin x minus 30. Does that make sense? Okay. You can just finish the drawing of it. You can leave out the last answer. Okay. When you come to class tomorrow, we're going to start with the sine and the cosine and the area rule. Are you fine with this? Okay. Go and practice drawing it some more at home. Over the weekend, you can redo these things, okay?